Bonsoir, Montréal-Python. Good evening, Montreal-Python, and welcome to Montreal-Python 95 Antiseptic Zebra. Bienvenue à Montréal-Python 95, Zebre Antiseptique. Vous pouvez peut-être le deviner par le nom de l'événement. C'est le dernier de notre série. Ensuite, on va avoir une nouvelle série de noms tout aussi aléatoires et loufoques. On vous invite à suivre nos événements pour les découvrir avec nous. Donc, avant de passer à notre programme pour ce soir, petit mot sur l'ordre. Vous pouvez vous rejoindre à nous sur Slack. Vous avez l'URL ici, mtlpy.org/fr/slackin. On est dans le canal Meeting. Et on a un code de conduite à Montréal-Python qui dit essentiellement « Soyez excellents les uns envers les autres ». Si vous voyez quelque chose qui ne vous semble pas excellent, trouvez-moi sur Slack. Je suis Yannick. Et dites-le moi, et puis ça va me faire plaisir de résoudre la situation. So, before we talk about the program for tonight, you can join us on Slack. The URL is right here. It's mtlpy.org/fr/slackin. We are in the channel Meeting, and we have a code of conduct at Montreal-Python, which is very simple. It basically says, be excellent between one and another. And if you see something that doesn't feel excellent to you, find me. I am Yannick on Slack, and I will do my best to resolve the situation. Our meeting for tonight is going to be shorter than usual, probably because it's summer and we want to keep some of the evening to go outside on the patio, drink some refreshing beverages. We are going to have a presentation by Andrew Cunningham on internationalization and localization. And I can't believe I said both of those without stumbling. And then we are going to have our traditional virtual happy hour on Jitsi. Alors, le programme pour ce soir, on va avoir une présentation de Andrew Cunningham sur l'internationalisation et la localisation. Et je l'ai dit en deux langues sans m'en faire jouer dans mes mots. Et ça sera suivi de notre 5 à 7 virtuel sur Jitsi. Et nos événements futurs, lundi prochain, on va avoir une autre soirée de programmation. Donc, si vous n'avez jamais assisté à nos soirées de programmation, c'est un peu faire du pair programming. On travaille sur un problème en commun et puis on a un document partagé. Il y a des fois que c'est Google Colab, il y a des fois que c'est un Jupyter Notebook. Et puis, lundi prochain, on va faire 2 sessions en parallèle. Une sur la programmation web en Django et l'autre sur les concepts de base de Python. Donc, peu importe si vous connaissez bien le Python ou si vous commencez, lundi prochain, ça va être un bon temps pour vous exercer le bout des doigts. Et puis après ça, on prend des vacances pour l'été. On n'aura pas d'événements pendant juillet et août, mais on revient en septembre. Et puis, je vous invite à voir notre calendrier à l'URL ici pour voir qu'est-ce qu'on va faire en septembre. Future events. Next Monday, we are going to have another programming night. And if you haven't attended one of our programming nights, it's basically pair programming. We come with a common problem, and then we have a shared document, either Jupyter Notebook or Google Colab or something else. And then we work on those problems together. And we're going to have 2 sessions in parallel next Monday. One is going to be on web development with Django, and the other one is going to be on Python basic concepts. So no matter if you know Python really well or if you're just starting, well, come next Monday and you'll be able to exercise the tips of your fingers. And then we're going to take some summer vacations. You can see our calendar for this fall on our website. So basically, we're not going to have any events in July and August, but we come back strong in September. Now, last but not the least, I have to thank our partners, FGNR, for consulting in Django, other web development projects. They're based in Montreal, and they're hosting our virtual happy hour tonight. And then there is Eddie, and I'm sorry, I still cannot pronounce his name correctly, but I'm going to try. Pamunkas, who took this beautiful picture of that blue snake. Isn't that beautiful? Alors, finalement, il y a notre partenaire FGNR qui fait de la consultation sur le développement web à Montréal, qui héberge notre 5 à 7 ce soir. Et il y a Eddie Pamunkas, je m'excuse Eddie, de mal prononcer ton nom, qui a pris cette magnifique photo du serpent bleu. Donc, c'est tout pour les annonces. Et puis, je vais inviter Andrew à se joindre à nous. Alors, Andrew,
Hello.
is the person who knows the most about internationalization and Unicode that I've ever met. He's worked on a bunch of projects in that domain. He's worked with the W3C, he's worked on the Unicode specification itself, and he's going to tell us about some of those topics. Andrew, the stage is yours.
Hello, everyone. One of the things when I'm writing Python code is that I never know what languages I'm going to have to use it with. So it tends to be flexible. And what I find a lot is that I usually have to go beyond the base core functions in Python. So I'll start by a little controversy and to frame what follows today. Python 3 has no overarching internationalization model. It's a haphazard accretion over time. Python core functions are language neutral and locale independent. And this can create unexpected consequences for the unwary. First, some terminology. What do I mean by internationalization? Internationalization is the process of designing software application for a web service so that it can be adapted to various languages and regions without engineering changes. Internationalization is about the architecture of a web service. So if I go to the Python documentation, there is a section on internationalization. Unfortunately, their section on internationalization specifically discusses the locale module and getText, i.e., it's about the infrastructure needed for localization rather than all aspects of internationalization in Python. If you do a search on Python internationalization, most of the stuff you'll find, 99% of it, will be on localization infrastructure, and localization, not on internationalization in its larger context. Localization, on the other hand, is the process of adapting the software or the service for a specific region or language by adding locale-specific components and translating the text. Not just text. Localization also involves the overall design, images, color, layout, white space, text expansion, user interface mirroring, and typesetting conventions. Globalization, a third term sometimes used, is actually an all-encompassing term. A service is globalized when it's both internationalized and multiple localizations are available, i.e., it's ready for the world. Python internationalization is a broad, poorly documented aspect of Python, and today we'll be looking at just a couple of aspects of that. One of the things I've been doing in my spare time, not that I have much of it, is to slowly document different aspects of Python internationalization. The key document so far is on sorting and collation in a language-specific way. So we'll be looking at some of the issues there very briefly. It's a long document with a lot of detail in it, but we'll just have a bird's eye view of it today. And we'll also look at a few other issues, but briefly. Locales are funny little beasts. In Python, we have a locale module to interact with a system's locales. But there are different types of locales. There's the Unicode's common locale data repository, and all the locales developed from that. And then there's the ISO 15897, which is more prevalent on BSD and Linux and Unix systems. The Python locale module, the commands in it and the logic in it are very much modeled on 15897. The key thing with locales is that locales aren't really suitable for cross-platform code. What's available on different platforms will vary, both in terms of the type of locale, CLDR versus the ISO 15897, but also in terms of what locales are actually available and what properties of the locales are supported. So for instance, if I am using Google Colab, I'm limited to 4 locales, the C locale, US English, something they call POSIX, and a few other odds and ends. So if I really want to do language stuff on Google Colab, I have to actually install all the necessary language support because the locales aren't there. The initial locale Python uses is the C locale. If you want to use something else, you have to explicitly change it. But the Python documentation has certain warnings in it. And essentially, all the information in the locale module documentation come down to set your locale early, set it to the system default, and do not change it, because locale changes are not guaranteed to be thread safe. You could, in one of your threads, you could be changing the locale, and suddenly that changes lots of other things everywhere else in the application. So basically, you import the locale, set the locale, and you set the locale to an empty string. This is Python's way of saying, set it to your system default. And there are different types of locale identifiers. The most common one we'll see is language and region, with an encoding identifier and sometimes some modifiers. On some language systems, they also add the Unicode script. So examples would be ja_jp.utf8, although that's sort of redundant because you can get away with just ga.utf8, except the locale, POSIX locales require the region. German, Austria, using ISO 8859-15. Greek in Greece. Traditional Chinese from Hong Kong, and has a modifier so that the collation is based on the pinyin value of the Chinese characters, the ideographs. Alternatively, some systems, like newer versions of Windows, will use a BCP47 based tag with either U extension or T extensions, which are managed by Unicode. So a simple one would be Australian English, simplified Chinese in the People's Republic of China. Now it gets fun because this uses the U extension, so it's basically Thai using the Buddhist calendar and using Thai numerals number system. This one is a lot more complicated. You have English reordering Greek characters before Latin characters, and then digits after Latin, but before everything else. Next one is Hindi, using native digits. This one is Canadian French, but ignoring case when it's sorting. So you can actually see the Unicode locale identifiers are actually quite powerful. You can actually tailor a lot just from the language code itself. But this only really works with PyICU, which is a Python wrapper around ICU4C. But you can tailor lots of different aspects of it. So it's actually quite powerful just from the locale tag. Quickly looking at collation. Collation includes sorting, indexing, searching, and matching. But I'll limit myself to sorting at the moment because that's of these collation functions, that's the only one supported in core Python. For indexing, searching, and matching, you need lots of other platforms integrated into Python. The default sort in Python, either using sort or sorted, will give you a locale neutral language independent sort. And it's based on ISO 14651, not on Unicode. The key thing to know about Python operations is some will be based on Unicode and some will not be. And some sort of are based on Unicode, but not quite. So I have a random string of characters, not quite random. I've deliberately chosen a few, and a couple of them, like agrav, are both pre-composed characters and decomposed sequences. So pre-composed here, decomposed over here. The interesting thing with this is that your uppercase characters sort before your base lowercase characters. So,
what? Dad, what's the time?
Sorry for the interruption. My daughter came in with a question. It's time for them to go to school. But the other thing you'll notice is that agrav sorts in two different places. One earlier in the list after A and one later in the list. So one of the key things here is that uppercase and lowercase characters are separated. They don't sort together. So, and that decomposed and pre-composed NFC versus NFD, NFD versus NFC data will give you different sorts. So if your all your data is NFD, decomposed, it will sort differently to if it was all pre-composed. You can, to some extent, normalize this a bit. So for instance, this particular piece of code, I use a Unicode data module and I case fold the strings, I normalize it to NFD, and that will give me a different sort to the default sort. So I'm actually getting the NFD and NFC, the decomposed and pre-composed characters, to sort together. You can also do locale-specific sorting. So you can import your locale module, set your locale, and then sort based on the locale using the key parameter. But you'll notice that it gives you better results than the raw sort. You can also tailor the locale sort. In this case, I'm taking the locale sort keys, case folding them. I'm doing a normalization called NFC case C case fold. Now, this is not a normalization form that's supported inbuilt in Unicode, so I have to create my own function. So basically, I normalize everything to NFKC, case fold it, and then normalize it to NFC. And then I do the comparisons for the sort. And that gives me a bit different, more tailored results than a standard locale. One thing I'd say before we go any further is if you're working on Mac or you need cross-platform code that will work on a Mac or on BSD or BSD-derived systems, you got problems. Most of the collation tables on these platforms are symbolically linked to a specific table, i.e., it will not give you language tailored sort or locale tailored sort. So there's no way to sort by locale on the Mac or on BSD, on FreeBSD, on NetBSD, and so on. So, and for me, with my code needing to run on Macs as well as other platforms, it implies that the locale module and using locale for sorting just won't work for me. So alternative solutions. There's a module called PyUCA, which implements the default Unicode collation element table, which is basically a language neutral approach. As currently, it supports Unicode version 10, but it allows you to download the appropriate collation key files from the Unicode site and use those instead, so you can actually use more recent versions of Unicode. The option I tend to use is to use PyICU, which is an extension wrapping ICU for C. So if you've got ICU for C on your system, and it's easy to install on a Mac using Homebrew, then that provides a way of creating cross-platform code that is locale sensitive. So in the code, I'm importing locale and collator from ICU. So ICU.locale and ICU.collator. I define my locale. I initiate a collator using that locale, and then I pass the get sort key for that collator to the key parameter for sorted. And that will give me a platform independent sort. So there'll be a consistent sort across all platforms that have ICU installed. So that's and it's also my preferred way of handling a lot of string operations as well. A useful module, Unicode data, but also a problematic module. This is one that's inbuilt into Python. It comes with any installer Python, but the version of Unicode supported depends on the version of Python you're running. Unicode data cannot be separately updated, so it's tied to what was created at the time. So if you're running if you need the latest version of Unicode, you always find you have to run the latest version of Python, an upgrade to the latest version of Python to get that support. But there are ways around that. Some of the uses, obviously it displays a lot of information about each character. So it's useful for testing against a subset of Unicode character database properties. You use it for Unicode normalization, and I use it for converting native digits to the Western Arabic digits that we normally use. So an example, importing Unicode data as UD, I pass it a string. I can then use the normalize function within Unicode data to normalize it to NFD. Then I can use the isNormalized function within Unicode data to test whether it is actually NFD. In this case, it's true. I can pass it a allow digit, and then I can use UC decimal to convert each digit in the string. One of the important things to remember about Python is that most numbers are treated as strings unless it fits very specific criteria. The number has to be a Western Arabic, made of Western Arabic digits. It mustn't have a thousands separator, grouping separator, and it must use a period for the decimal separator. Anything else won't be treated as a digit, but as a string. There are drop-in replacements for Unicode data. These are updated within a month or two of Unicode releasing a new version. Unicode Data 2 is a direct drop-in replacement. Unicode Data Plus and Tangled Up in Unicode have everything that Unicode Data has, but also have some additional Unicode character database properties that Unicode Data doesn't support. String operations, most are Unicode, but not all. Here's an example of a Dinka Wikipedia article title, and I title case it. And you'll notice that it doesn't title case just at the start of a string, of a word. It will uppercase within a word. One of the peculiarities of how Python defines a word. Anything within this word, you have combining diacritics because some of these combinations don't exist as single Unicode character points, so they have to be made up of two, open O and combining deresis. Now, any combining characters, any marks of any kind are not treated as alphabetic characters by Python. So any character after a non-alphabetic character is title cased by this function. Ways around it, roll out your own, or use PyICU. So for instance, if I use the word français and test if it's an alphabetic sequence, it is. But if I use the decomposed NFD equivalent, it's false. Français is not considered an alphabetic string because of the presence of the combining diacritic. But there are workarounds. I tend to use the regex module rather than re because it has much, much better Unicode support. It supports a lot of the Unicode properties and categories. And two of the things missing are different types of marks. that are required, that are word forming characters, but aren't considered as part of the alphabetic property. So basically everything with the alphabetic property plus these types of marks, and also I've added an interpunct for Catalan. Yes, I've had to work with Catalan in the past. And this will test whether a single character or a group of characters are alphabetic based on this definition, this expanded definition of alphabetic. So there are workarounds for some of the limitations. Likewise, working with digits, I tend to use ICU. This code I use for converting two native numbers in some of the code I write. Another headache is plotting. One of the most common libraries used a lot is matplotlib and its whole ecosystem. There's a lot of stuff based on this core library, including the default pandas plot, Seaborn, word cloud, and there's lots of other software. They all use matplotlib at its core. The problem with matplotlib is it doesn't support complex script rendering of fonts, and it does not support bidirectional text. So if you're doing stuff in Hebrew, Arabic, Syriac, or all sorts of different languages, nasty things happen. This is just a standard matplotlib bar chart with Arabic labels. One of the problems is that all the text is non-joining. It's using the isolated forms. It's not using the initial, medial, and final forms of the characters. Arabic characters can have up to 4 versions of a glyph, and it needs to be contextually rendered. The other problem with this string is it's not supporting BiDi, so the whole string is reversed back to front. So the joining is broken and the ordering is broken. Solution to that is to use mtlpyteam, which is also part of the matplotlib overall project. And it's an alternative backend for matplotlib. And it uses fry-by-d and rakim. Fry-by-d is used for the Unicode bidirectional algorithm support, and rakim is used for complex font rendering. So if I use that instead as my backend for matplotlib, and say I use it in Seaborn, I can do things like this. This is a Sarani Kurdish bar graph. The code I've used here can generate 2 versions, a mirrored version and a non-mirrored version. The text is correctly formatted, it's the right direction, and the special initial, medial, and isolated forms of the glyphs are used. The other thing it's doing, the code that I've used here, is it's swapping the Western Arabic digits for Eastern Arabic digits. So that gives you a quick overview of just some of the internationalization issues in Python and some of the workarounds and some of the alternatives. If you want more detailed information on some of these, go to that GitHub. That's where I'm slowly depositing all my notebooks and notes. And that's probably it. We're going over time. And if you have any questions, let me know. Back to you.
Thank you, Andrew. Everyone, if you have questions for Andrew, you can ask them either in the YouTube comments or on Slack, and I will be happy to relay them out loud to Andrew. Tout le monde, si vous avez des questions pour Andrew, vous pouvez les poser dans les commentaires YouTube ou sur Slack, et puis je vais les relayer de vive voix à Andrew. And I will start with one of my own questions. I have many questions because that's a fascinating topic, but I will limit myself to one for now. How does PyICU for, let's say, sorting compare with offloading these problems to the database? So I know I can ask MySQL or Postgres to sort using a specific locale. Are they doing the right thing? Or should I be worried about what they're going to give me and do it in Python instead?
Well, they're more likely to be using ICU behind the scenes as well anyway. So what you actually, if you use exactly the locale that they're using, then you'll get the same results, identical results. Both Postgres, MySQL, MariaDB, they would all be using ICU.
Okay, so
the difference is that Python, you can, within the databases, you only have a fixed set of locales. In Python, because you are interacting with ICU at a fairly low level, because the functions in ICU are very low level. And PyICU is a direct wrapper around those functions. So you sometimes find that you actually have to write some extensive code to make use of some of the functions because there aren't any user-friendly wrappers to facilitate all that.
Mm-hmm.
But that said, that gives you a lot of power. When I was showing some of the BCP47 locale-based identifiers, just so the locale identifier can control how ICU sorts and allows you to tailor it in very, very sophisticated ways. And that won't be available directly in the databases.
I see. So some of these very powerful sorting examples that you gave us must be looking at a fairly complex lookup table. So does that significantly impact performance? Can we still assume that sort is n log n, or is there a case?
Well, it really comes down to what you need to achieve and the purpose. One thing said, it will be slower than your native sort because your native sort has been optimized in lots of different ways. But that said, your native sort isn't going to give you the sort you need for French. It's not going to give you the sort you need for English. It's not going to give you the sort you need for lots of different cases. It's not going to give you Unicode-related sort at all. The most basic example would be all your uppercase characters, uppercase Z, is sorted before lowercase a. So zebra with a Z, capital Z, would come sort before apple with a lowercase a.
Yes,
so you just have to remember those peculiarities of the sort algorithm in Python.
Yes, I think the examples you showed us apply perfectly well for French, where characters with an accent should sort the same as the unaccented characters. But
in Unicode parlance, they have a secondary level of distinction. And casing, uppercase versus lowercase, has a tertiary. Where in Python, that native sort, they're all over the place.
Right.
Depending on your depending on what its code point is effectively in Unicode.
Excellent. That's a great motivator for us to heavily leverage that PyICU. I don't see any questions. So I'm going to re-emphasize everyone that you should not be shy. Ask your questions, and I will be happy to relay them to Andrew. I'm going to ask one last one of mine. A problem that I often see is that I cannot tell if a Unicode glyph is going to take one or more character width when I try to render it. And that makes it hard to predict my physical layout of the text. Is there an easy way to predict how wide a character sequence is going to end up?
There's probably a few different approaches. Probably the easiest way would be to typecast your string into a list based on graphemes rather than characters. If you typecast a string into a list, it'll break it up into individual characters. But you can use the regex module with find all, read.findAll, to split the string into graphemes. And a grapheme will be the base character and any combining characters that go with it to form one visual glyph. And this would be one way, and then you can just count how many characters or how many characters are in each string in the list. That's
Excellent.
one approach. There's other approaches as well. But
very good. I like that approach because it seems very flexible, which is much better than knowing specifically which font you're using and then measuring whatever.
Well, that's another issue, because the font you're using, there's two issues. How many characters does the grapheme take up is one issue. The second issue is how many glyphs the font uses to display that cluster.
Mm-hmm.
The ideal scenario is that a font will only use a single glyph for a cluster. That doesn't always happen.
Mm-hmm.
So you might have, say, an emoji made up of 5 or 6 code points. Some fonts will support that combination, like they'll support the proper rendering of the skin classifiers and color classifiers and various other things, and give you a single glyph. Other fonts will only partially support it, so that 5 or 6 characters may be rendered as 3 glyphs. So you've got both a component of, is this a grapheme cluster? How many characters are in the grapheme cluster? And then, what the hell does my font do with it? So they're very different questions. And in terms of the font, there's probably no easy way of doing it within Python.
Okay.
Unless you start looking at, you might be able to hook in a lower levels of rakim or lower levels of half bars, and Python wrapper around half bars, and then look at what your original string is and what the projected rendering is. But that would get to be quite complex.
I got it. So I thought there was an easy solution for it, but it looks like there might be some edge cases that I should still be aware of. Very good. Andrew, I think that is it for us. I don't see any questions. I'm very thankful for your time, and I know it's getting late for you in a different way than for us. I forgot to mention that Andrew is talking to us from the future. It's already Tuesday there in Australia, but as usual, we have our
my second coffee.
yes. So we have our happy hour that might be a little too early for Andrew. I'm going to put the address here, and the address is also in the YouTube comments, in the description, sorry, of this video on YouTube. So PyMTL Meet www.fjnr.ca/mp95. So I don't know, Andrew, if you'll be able to join us or if it's a great time for recaffeination for you. But we're going to meet over there. All right. Thank you, everyone. And that's it for us. And I'm going to see you, many of you, on next Monday at the programming night. And for the rest of you, I'm going to wish you a great summer. And we see you this September. Bye.